You think you're sitting still right now. You feel stationary. You're reading this, not moving, just sitting there. But you're not still. You're never still. Nothing is ever still. Not you, not this room, not the earth, not the sun, not anything in the entire universe. You're moving right now at hundreds of thousands of miles per hour. Multiple different motions all happening simultaneously, and you can't feel any of it. Why? Let me tell you something that's going to change how you see everything. Motion is not what you think it is, and the fact that nothing can ever stop moving, that's not just an interesting detail. That's fundamental. That tells you something deep about what the universe actually is. Let's start with you. Right now, you think you're sitting still, but the Earth is spinning, rotating on its axis at about 1,000 miles per hour. If you're near the equator, you're moving even faster. If you're near the poles, slower, but you're moving. The surface of the Earth is carrying you around in a giant circle once every 24 hours. Why don't you feel it? Because everything around you is moving at the same speed. The air, the ground, the buildings, all of it rotating together. There's no wind in your face because the air is moving with you. There's no sense of motion because motion is relative. You only feel motion when something changes, when you accelerate or decelerate. But it gets better. The Earth isn't just spinning. It's also orbiting the sun, moving through space at about 67,000 miles per hour. That's 18 miles every second. In the time it takes you to read this sentence, you've traveled hundreds of miles through space, and you don't feel that either. Same reason. Everything on Earth is moving together. No relative motion, no sensation. But wait, the sun isn't sitting still either. The sun is orbiting the center of the Milky Way galaxy, dragging the entire solar system along with it at about 450,000 miles per hour. We're screaming around the galactic center once every 230 million years, and the galaxy itself is moving, fawning toward other galaxies, part of a larger structure called the local group, which is itself moving through space. Add it all up and you're moving through the universe at over 1,000,000 miles per hour relative to the cosmic microwave background. And you're completely unaware of it because everything near you is moving at nearly the same speed. But here's what I want you to understand. This isn't just about planets and stars. This goes all the way down, all the way to atoms. And that's where it gets really strange. Take your hand, hold it still, keep it perfectly motionless. You think it's not moving, but the atoms in your hand are vibrating, shaking back and forth thousands of billions of times per second. They never stop. They can't stop. Why? Because temperature is motion. Heat is not a substance. It's not a fluid. Heat is the kinetic energy of atoms. When something is hot, its atoms are jiggling fast. When something is cold, they're jiggling slower. But they're always jiggling, always moving. Even at absolute zero, the coldest possible temperature, quantum mechanics says atoms still have what's called zero-point energy. They still have a tiny bit of motion. They can never completely stop. This is fundamental. Motion at the atomic level is not optional. It's built into the fabric of reality. Now let's go deeper. Inside those atoms, the electrons. You probably think of electrons as little balls orbiting the nucleus like planets around a sun. Wrong. Electrons don't orbit. They exist in what we call orbitals, regions of space where they're likely to be found. But here's the thing. Those electrons are not sitting still. They're in constant motion, not traveling in circles, but existing in a state of perpetual quantum flux. An electron in an atom doesn't have a definite position. It has a wave function, a spread out cloud of probability. And that wave function is constantly evolving, constantly changing. The electron is smeared across space, and that smearing is motion. Quantum motion, not motion through space in the way you normally think of it, but motion through possible states. And here's where it gets really weird. Why can't the electron just settle down? Why can't it find a nice comfortable spot close to the nucleus and just sit there? Because of the Heisenberg Uncertainty Principle. If you tried to pin down the electron's position exactly, its momentum would become completely uncertain. It would start moving wildly. The more you try to confine it, the more it resists. Quantum mechanics forbids stillness. An electron with zero momentum and a definite position cannot exist. The math doesn't allow it. So even at the smallest scales, motion is mandatory. Electrons must move. Atoms must vibrate. Nothing can be perfectly still. Now let's think about why things move in the first place. Why doesn't everything just stop? Here's the answer you don't want to hear. There's no such thing as a force that makes things stay still. Forces make things move. And once something is moving, it keeps moving unless another force stops it. That's Newton's first law. An object in motion stays in motion. But wait, you say, things do stop. I roll a ball across the floor and it stops. I slide a book across a table and it stops. So clearly things don't keep moving forever, right? But that's because of friction. Friction is a force. It's acting against the motion, slowing things down. But what is friction really? It's atoms bumping into each other. The atoms in the ball are hitting the atoms in the floor. Electromagnetic forces between electrons are pushing back, resisting the motion. Energy is being transferred from the ball's motion into heat, into atomic vibrations. The ball stops moving as a whole, but the atoms inside it are now moving faster. The energy didn't disappear. It just got redistributed. The organized motion of the ball became disorganized motion of atoms. That's heat. In empty space, there's no friction, no atoms to bump into. So if you throw something in space, it keeps moving forever. Exactly the same speed, exactly the same direction, forever, unless something hits it or gravity pulls on it. The planets are doing this right now. They're moving through space, and there's nothing to stop them. No friction, no air resistance. They've been moving for billions of years, and they'll keep moving for billions more. But why are they moving at all? Where did that motion come from? Go back to the beginning, the Big Bang. Everything in the universe was created in a state of motion. Space itself was expanding. Matter was flying apart. Particles were created with kinetic energy, moving in all directions. The universe has never been still. It started moving and it's still moving. Every motion you see today is in a sense leftover energy from the Big Bang. The Earth spinning, the sun orbiting the galaxy, the atoms in your body vibrating. All of it traces back to that initial explosion of energy 13.8 billion years ago. And here's the thing that should really mess with your head. Motion is relative. There's no absolute reference frame, no cosmic background that's truly at rest. When I say the Earth is moving at 1,000 miles per hour, I mean relative to the center of the Earth. When I say the Earth is orbiting at 67,000 miles per hour, I mean relative to the Sun. But the Sun is moving too. Relative to what? The galactic center. But that's moving too. Relative to what? Other galaxies. But they're moving. Relative to what? There's no answer. There's no absolute stillness anywhere in the universe. Everything is moving relative to everything else. Motion is all there is. The universe is a churning sea of relative velocities. You can't point to anything and say that's not moving, because moving compared to what? There's no fixed point, no anchor, no absolute rest frame. Einstein figured this out. Special relativity says the laws of physics are the same in all reference frames, moving at constant velocity. There's no experiment you can do to determine whether you're moving or standing still. Motion is fundamentally relative, but gravity is different. General relativity says that acceleration, changing velocity, that's absolute. You can tell when you're accelerating because you feel a force. When the car speeds up, you're pushed back in your seat. When it turns, you're pushed to the side. Acceleration is real, but constant velocity completely relative. If you're in a spaceship moving at 1,000,000 miles per hour in a straight line, no windows, no outside reference, there's no experiment you can do inside that spaceship to determine you're moving. You could just as easily say you're sitting still and the rest of the universe is moving past you. Now let's get to the really deep question. Why can't anything stop moving? At the classical level, big objects, it's because there's always something pushing or pulling. Gravity, friction, electromagnetic forces, something is always acting. Perfect stillness would require perfect isolation, no forces, no interactions, and that doesn't exist anywhere in the universe. At the quantum level, it's deeper. The uncertainty principle forbids it. Zero motion means zero momentum, which means you know the momentum exactly. But if you know momentum exactly, position becomes completely uncertain. The particle could be anywhere in the universe. That's not a particle anymore. That's nonsense. So quantum mechanics says particles must always have some uncertainty in momentum. And uncertainty in momentum means motion. Even in the ground state, the lowest energy state, particles are still moving, still jittering, still uncertain. And here's the beautiful part. That jittering, that quantum motion, that's what holds atoms together. Electrons can't fall into the nucleus because if they did, they'd have a definite position. That would require enormous uncertainty in momentum. They'd be moving so wildly they'd escape. The atom would fly apart. So atoms exist in a balance. Electrons want to be close to the nucleus because of electromagnetic attraction, but quantum mechanics forbids them from being too close. They have to keep moving. They have to spread out. That's what gives atoms their size. The fact that nothing can stop moving is the reason matter exists. If electrons could stop, they'd collapse into the nucleus. Atoms wouldn't have structure. Chemistry wouldn't work. You wouldn't exist. Motion isn't just a feature of the universe. Motion is the universe. Everything is process. Everything is change. Everything is becoming. The ancient Greek philosopher Heraclitus said you can never step in the same river twice. The water is always flowing, always changing. He was more right than he knew. You can't step in the same river twice because the river is moving, but you're also moving. The earth is moving. The atoms in your foot are moving. Nothing is the same from one moment to the next. Reality is not a collection of static things. Reality is a network of processes, events, interactions, motion. When you really understand this, when you see that nothing ever stops, that motion is woven into the very fabric of existence, it changes everything. You stop thinking of objects as things and start thinking of them as patterns, temporary configurations of matter and energy that persist for a while and then dissolve. You're not a thing, you're a process, a pattern of atoms that's constantly changing, constantly exchanging matter and energy with the environment, constantly in motion. The atoms in your body right now weren't there 7 years ago. They've been replaced. You're like a wave in the ocean. The wave moves, but the water doesn't. The pattern persists even as the substance changes. And all of this motion, all of this change, all of this becoming, it never stops. It can't stop. The universe doesn't have a pause button. There's no freeze frame. Everything is always moving, always changing, always evolving. The earth spins, the sun orbits, galaxies collide, atoms vibrate, electrons fluctuate, space itself expands, motion upon motion upon motion, all the way down, all the way up, everywhere, always, and you're part of it, right now, moving through space at 1,000,000 miles per hour, made of atoms vibrating trillions of times per second, made of electrons that can't sit still, made of quantum fields that are constantly fluctuating. You are motion. The universe is motion, and there's no stopping it, ever. That's not a problem. That's beautiful, because motion is life. Motion is change. Motion is possibility. A universe that could stop would be dead, static, frozen, boring. Our universe never stops. It never will. And that's exactly why anything interesting can happen at all.